Alright. Hello everyone. Tonight I'm going to present to you a theory that I call the universal theory of light, gravity, and magnetism. They all derive from the same fundamental essence. And the three of them are simply variations of that fundamental essence. The most basic fundamental essence is that all matter in the universe wants to move together as one. With light, it is the vibrational motion that it wants to move with. With gravity, it is the trajectory motion that it wants to move with. With magnetism, it's the spin motion that it wants to move with. If the basic essence of all three of these is the same thing, that would help explain why they all move at the same speed. I only know of three things that can pass through a vacuum: light, gravity, and magnetism. It would make sense that if those are the only three things in the universe that can pass through a vacuum, that they are all being derived from the same thing. I'm proposing to you that light, gravity, and magnetism, they're all forces. One of the biggest scientific debates of all time is that of wave-particle duality, and I've read that it goes all the way back to Aristotle. So, with wave-particle duality, scientists are trying to decide, is light a particle or is it a wave? And even to today, scientists have never found a particle of light. The modern scientific thought right now is that there's a photon. But because they can't find the photon, they're calling it a massless particle. So what I'm proposing to you today resolves that issue. Basically, a massless particle, that doesn't really add up, right? So it doesn't really make common sense. So then how do we see light? Let's go to the next step. So the sun, remember we're talking about three different forces, right? We're talking about trajectory. We see it moving through space. Okay, gravity. Everything wanting to move with it. The sun moves, pulls everything with it. Gravity. Magnetism, I'm proposing to you, is caused by the spin. But let's go to light. Light, what I'm proposing to you. You have a giant sun, huge sun, compared to the Earth, right? Now, all the particles, all the atoms on the surface, at least, are vibrating very fast. The sun's particles are all vibrating quickly. And when the Earth turns and its surface faces the sun, its particles begin to want to vibrate with the sun, with the particles on the sun, trying to move together with it. So how do we see that? What happens then, I'm proposing that our eye is actually a receptor that will actually vibrate. The inside of the eye will actually vibrate at whatever it faces. So if the sun is vibrating rapidly, it causes the other particles on the Earth that it's facing to vibrate rapidly. When the eye looks at it, the interior of the eye, the back of the eye, is actually vibrating. And so we already have the concept of frequencies, right? Frequencies, light frequencies. One of the concepts of light frequency is basically a rate that something takes place. The faster the frequency, the faster something's taking place. So as the sun vibrates rapidly, it causes the molecules and the atoms on Earth to vibrate rapidly. Some of them vibrate at different speeds. They might not be able to match the sun exactly at the same speed. So whatever speed they end up vibrating at, the eye can detect that. Now, and that can be expanded then to the telescope. Whatever, let's say the telescope, right? Let's pretend this is the giant telescope. Whatever it's pointing at in space, it vibrates, right? Vibrates and picks up the vibration of whatever's out there. Let's talk about magnetism for a moment. Think about everything that you know related to magnetism, almost everything that we know related to magnetism, has something to do with spin. Okay? The Earth spins, and guess what? It has a magnetic pole, right? North and south, based on the spin. When we create electricity, what are we doing? We're spinning either a magnet or a coil around the magnet. A lot of other things line up and make more sense than they used to make in the past. And I'm just going to draw out one that I think is probably the most important, to me the most impressive in regard to, wow, this is freaking wild. And that is, based on this theory, I'm going to explain to you how black holes and dark matter derive from a similar essence. Okay, but before we get there, let me give you a little bit more info. We're talking about, again, things vibrate, right? Things vibrate. So if they vibrate, it causes something else to vibrate. It tries to move with it. So that's actually what light is, and our eyes interpret that different frequencies of speed. Our eye will then interpret that as color. So let's say now that something no longer vibrates. It stops vibrating. Then if we point our telescope at it, it will not cause the telescope to want to move with it, right? Because the object has stopped moving completely. So if an object in space is not vibrating at all, the telescope will not see it. Now this is the basic essence of how a black hole and dark matter are derived from the same essence. What happens with a black hole? Current theory says that light cannot escape, right? But that's in a concept of light being particles. Under this theory, what I'm proposing to you is gravitational force increases. It compresses the matter, right? It gets smashed more and more and more. So on the surface of this black hole, as more and more matter collects, eventually that matter will get compressed so tightly that it cannot vibrate anymore. So if we were to take our telescope and point it at that black hole, it would no longer vibrate, which means it would no longer make the telescope vibrate. The matter on the telescope pointing at it vibrate, so we would no longer see it. So it's not a concept of light not being able to travel, which again, the photon we've never discovered, but it's a concept of that matter not being able to move anymore on the top of the black hole, and therefore not causing the telescope to want to move with it. So we see nothing. It's completely black. Let's take a look now at dark matter. Dark matter then would derive from the same essence as that of the black hole, in that the matter is no longer moving. However, with the black hole, it's no longer moving because so much matter is collected, it's compressed to the point it can no longer move. Because of the tremendous gravitational force, it can no longer vibrate. Whereas with dark matter, if something is so far away from, let's say, the sun, from any light source, matter gets so far away. We believe in our universe that the universe is expanding. Even right now, they believe it's at an increasing speed. It's actually going away faster, right? So think, as something gets further and further away, what happens? Everything starts to separate, right? It gets further and further away from everything else. So the further the items get away, the further they get away from a source of heat, the cooler they're going to get. The cooler these items, this mass, these particles are going to get. So it very well may be possible that dark matter, all this dark matter in the universe that has this gravitational effect, the way this has come about is that the matter itself is no longer vibrating because it's so far away from a heat source. It's become cold. It no longer vibrates. And so if we point a telescope at it, the telescope will not try to move with it because the dark matter is not moving anymore. So we can't see it. Alright guys, hope you have a good night. I'm on expedition filming the XD adventure vlog. But as I'm out doing that, got some other material to present to you. So leave your comments below. Hope you guys have a great night, and look forward to sharing more info with you soon. Bye.